In this video, we're working with properties of exponents to multiply radicals together and write in reduced radical form. So when we have multiplication of radicals, we're looking at problems that either have the same index, and those are the easy problems where we just multiply our radicands together. And then if we have problems that sorry, my screen was frozen. And if we have problems that have a different index, that's when we have to rewrite it as an exponential form in order to get the same radicand. So the rule with multiplying radicals is that if I have the same index, so this first problem, they both have an index of 5, then I can take and multiply the radicands together. So I'm going to multiply 16 times 8. And so this question is asking us then to simplify the expression, the fifth root of 128. So what we want to do is take 128 and find its prime factorization. So remember that when we're factoring, we always want to start with the prime number 2 and see if it goes in evenly. Once 2 doesn't work anymore, we move on to 3 and then 5, 7, 11, 13. Those prime numbers. So this one though is going to end up being a power of 2. So 128 divided by 2 is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And then 2 is prime. I'm going to stop there and not go to 1 like I normally do just because of space. So remember that the index tells us what's staying inside the radical and what's allowed to leave. So in reduced radical form, I'm taking out any powers of 5, meaning if I have a group of 5 of the same number or an exponent of 5 on a variable, then that leaves the radical because it's the fifth root is the base. So I have 5 2's, 1, 2, 3, 4, 5 2's that can leave the radical. So these 5 2's are going to leave as a single unit. And then I still have my fifth root. Whatever I have left is going to go back inside. So I have to multiply everything together no matter what, whether it's outside or inside. And so the 2 2's that are left over are going to stay inside the radical. So our answer for this is going to be 2 times the fifth root of 2 times 2 is 4. So the fifth root of 16 times the fifth root of 8 is 2 times the fifth root of 4. What changes when our index is different within each one, so if we have different indices, we need to rewrite them as exponential form in order to make a common index. So remember that whatever's inside the radical, we're going to put that in parentheses. So we have 8x, and this is the sixth root. So remember that there's technically an imaginary 1 here. So that's going to be to the 1/6 power. Times we have 2x, which is in a cube root, so that's going to be to the 1/3 power. So since both things are under the radical, the 8x and the 2x, I'm putting those pieces in parentheses so that I don't forget that each one is being raised to that power. So what I want to do is to make a common index, aka a common denominator. So for this problem, it's not max, we're going to make a common index. In this case, our common index is going to be 1/6. So that means we're making a common denominator for our power. So we're going to multiply this 1/3 by 2/2 so that they'll both have a denominator of 2. So that means that we have 8x to the 1/6 power times 2x now to the 2/6 power. So if we think about that back as radicals, now that we have a common denominator, let's rewrite as radicals. So notice that we actually didn't change anything with 8x to the 1/6 power. So we still have that sixth root of 8x. Times now we have x in parentheses. That was to the first power. Now we have the 6th root of 2x squared. So since we have the same index now, we can multiply these together. So we have the 6th root of 8x to the first power, so just 8x, times 2x squared. So that means we really have 2x times 2x because it's squared. So if I multiply these things together, that gives me the 6th root of 8 times 2 is 32. And then I have x cubed. When I'm looking at reduced radical form, I want to see if any of these can leave the radical. So looking at the variable, my x is to the 3rd power, I have to have 6 x's to leave. So that means that the x cubed has to stay. Also, remember that when we factor 32, 32 is 2 to the 5th power. And so that's not allowed to leave the radical either. So that means that the answer for this problem is just this expression, that 32 and x cubed are neither have factors of a perfect 6th. So that's how we simplify radicals with different indices.